8.6, solving rational equations and inequalities, right? So the purpose of this lesson is to learn how to solve equations like this, rational equations. Now there's a little process to this. So as always, we'll have a little steps right here. And step 1 is to find your restrictions. If you remember when we did that earlier, find restrictions. Always do it to the denominator equal to 0. Right, because those numbers you can't be. So find your restrictions. And then 2, we're going to find the LCD. Basically, like we're going to try to add these things. We're going to find the LCD, and we're going to try to make them all have this common denominator. Make all fractions have a common denominator. Right, so just like we're trying to add them, like, okay, I want these all have this common denominator, just find the LCD. So basically, what's everything missing? Well, I have an x plus 3, I need that. Right, so that's missing x plus 3, multiply that by an x plus 3, multiply that by an x plus 3. But what is this missing? Well, there's 2 and a 10. 10, they both go into 10, so your LCD is this. 10 x plus 3. So you want them all the same bottom, the same base. That's gonna be, they all need to be that. Right, so you need x plus 3 for all of them. You're going to need 2 and a 10, so which one's bigger? 10 is. They both go into 10. So you're going to make them all have the same LCD. Once you get them all have the same LCD, then all we do is we're going to solve the numerators. And then last, we're going to check our work. Check answers. How do you check your answers? Just make sure it's on one of the restrictions. So that's the process. Find your restrictions. Let's do that now. So my restriction here, I only have one problem here. X plus 3 equals 0. So x can equal negative 3. Right, no matter what I get as my answer, as long as I don't have negative 3. If negative 3 is the answer, it's bad. Everything else is fine. I just can't have a negative 3, I'll make this 0. So I check my restriction. So I can't have negative 3. Find the LCD. So like we talked about, here's the LCD of everything. So we're going to try to make everything have the same LCD. Just like we did earlier. So it's kind of like a review of that lesson for some part of it. We're all going to try to get 10 times x plus 3. Right, that's what they all go into. Now we look at the top one here. Right, if I want this to go to 10x plus 3, I'm going to multiply by 10 over 10. So 2 times 10 is 20. This one's probably missing the most, right? All you have is 2. You need to get to 10x plus 3. So you're missing a 5 and an x plus 3. So multiply everything by 5x plus 3. And you're going to get 15. 3 times 5 is 15, x plus 3. I'll simplify that more later. And then finally over here, all you have is the 10. You're missing the x plus 3. So multiply by x plus 3. So this will be 19 times x plus 3. Now the whole idea here is once you have that, well, if you notice, they're all the same denominator. All you have to do is solve the numerators. Just solve this problem right there. Right, so once you get this common denominator, you just solve the numerator. So you get 20 plus this. Let's distribute 15x plus 45 equals. Let's distribute 19x. 19 times 3 is 60 minus 3, so it's 57. Right, now it's a normal algebra problem. Let's subtract 15 from both sides. 20 and 45 is 65. So let me do this first actually. 65 equals 4x plus 57. All right, let's subtract 57 from both sides. So you subtract that, you're going to get 8. And then divide by 4. X equals 2. Right, so that's my answer. Just check my answer. So you could plug in and see if it works. That always works. But I'm just going to make sure it's not in my restriction. My restriction says it couldn't be negative 3. I'm at 2. I'm good. I'm all good. If you plug in, there's be no issues. There you go. So again, just to kind of go over it, right? What do? We found our restrictions because we'll make sure our answer works. So I couldn't be 3, negative 3. Once I did that, I was like, you just treat it like you're going to try to add all these. So try to find the LCD of all of them. So our LCD of all of them was 10x plus 3. So we wrote all of it in that term with a common denominator. And once you did that, all we had to do was solve the numerators because all the bottoms are the same. And then you check your work and make sure you're good. So that's the process we're going to do over and over again in this lesson. Starting with the next one. Example 2, right? So first we'll start with our restrictions. So right here's the only thing I have to worry about. x minus 4 cannot equal 0, because otherwise we're going to divide by 0. And you get x cannot equal 4. So again, as long as I don't get 4 as my answer, I'm good. And then next thing I do is find the LCD. Again, the easy way to think about it, if you're going to add them, if you're going to add them, what's the common base? Well, I need the x minus 4. That's for sure. And I got to find the LCD of 12 and 48. What do they both go into? 48. Right? 12 times 4 is 48. So that's my LCD. Now let's rewrite this with all the common LCD. This is 48, that plus 48 x minus 4 equals 48 x minus 4. Right? And then we have to look at what do I need to multiply so I could get that as my base. In this case, you're missing x minus 4 and you're missing 4. Right? How do you get 12 to 48? You times it by 4. But you're also missing the x minus 4. 4x minus 4. That's going to give me 28 x minus 4. Right? 4 times 7 is 28. The middle one, you're just missing the 48. Right? It has the x minus 4 already. That's gonna suck in a second. 9 times 48. And then over here, right, we already have the 48, we're missing the x minus 4. So we're gonna go x minus 4, x minus 4. So it's gonna be 55 times x minus 4. Right, so that's our setup. Now, once you have all the bases the same, we could drop them and just solve the numerators. So we're just gonna solve this. Right, so 28, distribute that. Oh, not pretty. Minus, let's see, 4 times, so 28 times 4, 32, 3, that's 8, so 112. Plus 9 times 48. Oh, that's gonna suck too. Let's see, 48 times 9, 72, 36, 36 plus 7, 43. Equals, distribute to 55. 55 times 4. 220. So we have this, right? And once you get to this, down to this, it's a normal problem. Solve and add. Right, so I could combine these. I get 5, 2, 1, 28x plus 55x minus 220. Subtract 28x from both sides. Add 220. And I get 5, 4, 3 equals, what's that, 27x? So it's something to that effect. And actually, there's a little mistake right here. There should have been a 2, I just noticed. That makes this 20 and makes this 320. Not much prettier though. The rest is right. Divide by 27. And you get some fraction. That's not 4, so we're good. But that ugly number is my answer. Again, it's the same process, right? Again, just all we're going to do is find a restriction, so make sure we don't get that as an answer. Basically, try to add them all up. So if you're going to add all these fractions up, what would be the LCD? So find the LCD. Once you get the LCD, like you're ready to add them all, then just solve the numerators. And then once you do that, you just solve like normal, you get your answer. That's our first way of doing it. That's kind of, for a lot of people, considered a long way. There's a shorter way, but in my estimation, this is the way that people like the best. Let me show you a shortcut way, though. Which is, what we do here is we multiply everything by the LCD we find. Right, so it kind of works the same way. Only difference now is once we find our LCD, after we do that, we're going to multiply everything by LCD. What that does is get rid of the fraction. So let's practice here. So 5 over y minus 2 plus 2 over 1 equals 17 over 6. So let's find our LCD. Actually, let's find a restriction first. Right, look at this right here. Y can't be 2. That's what makes it 0. So y can't be 2. Right, y minus 2 equals 0. Solve it. Y can't be 2. So that's our restriction. Let's find LCD. So it's like if you're going to add all these up, what will be the bottom? It'll be 6 times y minus 2. Because you need one of each. I need the y minus 2. And then 6. Now again, I'm not looking at the 2 and the 6. That's different. This is like locked in. I need that y minus 2. That's something separate. I need a 6 also. So again, last time I'll just multiply everything by the, I'll just have the common denominator and then solve the tops. This time let's try the little faster way, which is multiply everything by the LCD. We're going to multiply everything by this. So multiply this by that. We're going to multiply the 2 by 6y minus 2. And we're going to multiply this one by 6y minus 2. I guess this is a shortcut way. So you multiply everything by the LCD. Now look what happens. Over here, the y minus 2's cancel out. You just get 6 times 5, which is 30. On the second one, nothing cancels out. This is nothing in the bottom. So this 2 times 6 times y minus 12. So let's put 12 y minus 2. And on the last one here, the 6's cancel out. And you get 17 times y minus 2. So then we just solve like normal, right? Distribute. See some more of my bad math. 12y minus 24 equals to 4. Distribute 17y minus 34. As always, the simplify first, right? 30 and negative 24 on the same side, so I just add them. So I get 12y plus 6 equals 17y minus 34. Again, because they're on the same side, you just simplify. Now I'm trying to get the y's by itself, so let's subtract 12y and add 34. And you're going to get 40 equals 5y. 5 by 5. Y equals 8. Which is, again, it's not a restriction. I could try plugging this to get the right answer, but you should. That's the answer. So again, it's a little faster way. Just multiply everything by the LCD. It's the same idea. This just skips this kind of like step of trying to find the common denominator. Let's do another one. So this one. Let me do the same idea. Let's do this in a shortcut way. Now do the next one without. Right, so the shortcut way I'm going to find, well, let's first I got to find my restrictions. Right, so it set this equal to 0. You get your z can't be negative 1. Set that equal to 0. Your z can't be 1. And that's the same thing. So next, let's find the LCD. So these are always factored. I could factor this. Z minus 1 is z plus 1. Well, my LCD is going to be that. Z minus 1. Right, because they have a z minus 1. That has a z minus 1. And z plus 1. Because that has a z plus 1. That also has a z plus 1. That's my LCD. Again, if we're doing the shortcut method, just multiply everything by that. So we're going to multiply this by z plus 1, z minus 1. Multiply this by z plus 1, z minus 1. And multiply this one by z plus 1, z minus 1. And just like before, over here the z plus 1's cancel. And you're left with 2 times z minus 1. Over here the z minus 1's cancel this time. And you're left with negative 1 times z plus 1. And on this one, they all cancel. The plus 1's cancel and the minus 1's cancel. And you're left with only negative 2. So again, it's a little bit of shortcut. I'm going to go back to the way in a second. But the slight shortcut is once you get the LCD, multiply everything by the LCD. You have to multiply everything by it. Once you do this, you can distribute and just solve a normal math problem. Distribute, don't forget the negative. Right, so let's add terms. I can add the z's together and I get z. I can add these together. I get negative 3 equals negative 2. Add 3 to both sides. And I get z equals 1. There's one problem though. That was one of my restrictions. So that actually can't solve. We have no solution. Right? No way to solve this problem. The one answer I got was a restriction. Doesn't work. If I try to plug it back in, I'm going to get a 0 right here. Okay, so that's the second one we did with the shortcut. Let's do one more with the extended version, with the first way. Okay, so this one, let's do it the old-fashioned way. So, just like before, we're going to do the restrictions. Well, to do that, let me factor this. Now that factors to x minus 6, x minus 8. Oh, what a coincidence. Not really. So, let's solve it, right? So the denominator equal to 0. So, x cannot be 6 or 8, right? What makes this 0? 8, 6, same thing. So that's our restrictions, right? Now let's find the LCD. Now if you notice, you need one of each, right? I need an x minus 8. That doesn't have one. That has one. And that has one. And you need x minus 6. So that's your LCD. Now again, from here you can do two ways. You can multiply everything by the LCD. Stuff cancels out and just work that. Or you can try to get the common denominator. I'm gonna do that this time. So this is going to be x minus 8, x minus 6, x minus 8, x minus 6 equals x minus 6, x minus 8. right? Like that's my lowest common denominator. Now over here, how do I get from here to there? Well, it's missing an x minus 6, so it's multiplied by x minus 6, x minus 6, and I get 14 times x minus 6. Over here, I already have the x minus 6, I'm just missing the x minus 8, so it's multiplied by x minus 8. Just like we're trying to add all these, right? You try to get the common denominator, multiply it out. Now this one has everything you need, so you don't need to multiply it by anything. You get that. Right, and once you get this, now all you do is you solve the top. So 14 times x minus 6 minus 5 times x minus 8 equals 82. Now you just do some math. 14x minus 6 times 10 is 60 plus 24. So negative 84 minus 5x. And then plus 40. Remember, two negatives make a positive. Equals 82. Now again, this is all on the same side, so this add up like terms. So this is 9x, because again, the same side, just add them up. Same thing with these two, negative 84 and positive 40 is negative 44. Equals 82. Add 44. And I get 9x equals 6. 126 divided by 9. 9 goes into there 1 times 36, 4. So 14. Again, notice it's not one of my restrictions, so I'm good. That's my answer. Right, so that's how you solve a rational equation, right? Again, just find the restrictions, find the LCD. Once you find the LCD, you can either multiply LCD by every single term, and then you get something like this. Or you just try to find the common denominator and then solve the numerators. Either way, you get your answer. Once you get your answer, make sure it's not one of the restrictions, and you're good. Next up, though, application problems. So we're going to focus on two types of application problems. One being a mixture problem, that's what we're going to do right here, and then one being a work rate problem. So first up with a mixture problem. So in this, look at the best way to do this by example. Jimmy adds 60% fruit juice to a solution of 50 milliliters of a drink that is 10% fruit juice. How much of the 65% fruit juice solution must be added to create a punch that's 35% fruit juice? So essentially, we're like managers at Jamba Juice, and we're trying to create a nice new drink. Right? So first thing, let's make a little box. Let's get our Willy Wonka out of here. It's an alright box. Okay, so this is the way it's going to work, right? Look what we're adding. We're adding 65% fruit juice, so 65% juice. And then we're adding it to a 10% punch. And then we're going to get a mixture. So the ways these generally work. We get some mix. Okay, so what we need here is this. We need the amount. We need the value. That's an equal to our total here. Right, so what do I mean by that? So first let's talk about our amount here, right? So Jimmy's adding some amount of 65% fruit juice to his 15 milliliters of 10% fruit juice. And we're trying to say, hey, how much should he add of that 65% to get 35% fruit juice? So this, we don't know how much. We're trying to figure out how much he's going to add of that. I do know I have 15 milliliters of the 10% one. Right, now again, now think about this logically. The mixture, right? I'm adding this to that. So if I'm adding this X amounts is 15 milliliters, I'm going to get 15 plus X, or X plus 15. Right, just add these two down. Let's talk about the value. In this case, that means what percent of fruit juice. This has a 65% fruit juice. This has a 10% fruit juice. And look on this one, I want a 35% fruit juice. So that's the value for all of these. Then how does this last row work? Well, it always works the same way. We always multiply the amount times the value to get the total. So in this case, I have 0.65x. Over here I have 10% times 15, or 1.5. And over here I have 35% times 15 plus x. I'm just going to leave this as 35 times 15 plus x. You don't have to be a hero. That's fine. So you get that and you're like, okay, great. What's next? Well, what's next is we want to come to an equation with this. And it's always the same way that we make this equation. We add this fruit punch here, which is this fruit juice, plus this fruit punch to get our mixture. right? We add these two columns that get that third column. And that's our equation, right? It's kind of the amount times value equals the total. What's the amount of 6% of 65% free juice we have? We don't know. And then in this case, what's the amount of 10%, 15% free juice we have? 10% times 15 milliliters. That came out terrible. I'm sorry, guys. And then our mixture is going to be this plus that, which is x plus 15 times its value. And then from here, it's just a math problem with ugly decimals, but it's still just a math problem. Right, I need 0.35 times 15. I'm going to use my fancy calculator. Got to turn it on. 0.35 times 15. I get 525. Plus 0.35 times x, 0.35x. Right, now it's just a normal math problem. Let's solve it. Subtract 0.35x from both sides. Subtract 1.5 from both sides. Over here I get 0.3x, or 30x. Over here I get 5.25 minus 1.5. So I should be able to do that. That's 3.75. Let me double check this to make sure. 5.25 minus 1.5. So yeah. And then all we do here is divide by 0.3. And you get 12.5. So x equals 12.5. So that's how much, again, what's that going on? It's how much of the 65% fruit juice I gotta add to get this one. I gotta add 12.5 milliliters to make my Willy Wonka creation of this mixture to be exactly 35% fruit juice. So that's a mixture problem. Next type of application problem we're gonna work on, we're gonna skip that one. We'll do a work problem. So I love these work problems. So let's talk about how to do them. Here's a general idea. The way we do this, it's like work is number of jobs over time it takes. So this will make more sense in a second. It took Anthony and Travis 6 hours to rake the leaves together. So the rate together is 1 over 6. So they work together. The previous year, it took Travis 10 hours. It took 10 hours to do it alone. So Travis's rate, he could do 1 job in 10 hours. Again, together he could do 1 job in 6 hours. How long will it take Anthony to rake the leaves by himself this year? So Anthony is 1 job in X hours. We don't know. So the way we're going to solve this is, well, if I take Travis's time plus I add Anthony's time, I get their time together. So if I take Travis's 1 over 10 plus Anthony's 1 over X, which I don't know because I'm trying to find it, it equals 1 over 6. And that's our problem. We're just going to solve that. Now the way we solve this, like we talked about before, you got to find the LCD. Right? And then in this case, what do 10, X, and 60 all go into? Well, this thing about 60 and 10. They both go into 30. That's the easiest thing to go into is 30. And then we need the X. So now it's your choice. You can multiply everything by the LCD, or you can just try to get them all to have the same LCD. It's really the same thing. Alright, how do I get from 10 to 30x? Well, I'm missing a 3x. So I get 3x right here. How do I go from x to 30x? You're missing a 30. So 30. And then how do you go from 6 to 30? You're missing a 5x. Right, and then once you get this, once you have the same denominator, you can just solve the tops. And you get 3x plus 30x, 30 equals 5x. Do some simple math. 30 equals 2x, and x equals 15. Anthony's apparently slow, and it takes him 15 hours to do it by himself. But that's the way we're gonna do. We'll do normal in a little bit, but if the work problem is all you do is okay, it's a work rate problem, which means you get a person's rate, 1 over that rate, plus another person's rate, 1 over that rate. Add them together, and you get 1 over the total rate together. That's all it is, right? I go, oh, it takes them 3 hours to do something. It takes another person 2 hours to do something. How long does it take them to do together? You do that, and you just solve it. That's how you do work rate problems. You just add the rates together to get their total rate. So now let's go back and let's review a couple of these. So let's review the mixture problem. So in this one, Sarah has 10 pounds of dried fruit selling for $6.25 a pound, and then she has she has some mixed nuts she's selling for $4.50 a pound, and she wants to make a trail mix selling $5 per pound. So that means she's a hipster, and she probably wants to sell this at Trader Joe's or something. But let's help her out. So look at, they already have it set up for us. How many pounds of dried fruit? It said 10. She wants to know how many pounds of mixed nuts, so that's her X. And now remember, our trail mix already, we're adding this plus that, so it's me 10 plus X. Right now, her mixed nuts, she sells them for $4.50 a pound, and she wants to sell the mixture for $5 a pound. Right? And now the total price, and then remember the way we do this, we multiply these together, so it's be 450x, it's be 5 times 10 plus x. Right? That's how mixture problems, right? You add down and you multiply across. Well, you add down here and here. That's something different. Anyway, once we do that, how do we write our equation? Like we did last time, it's all about the last box here, right? So the idea is you're adding dried fruit plus mixed nuts to get the trail mix. So our equation is going to be 6.25 times 10 plus 4.550x equals 5 times 10 plus x. And once you get that, it's just solve a normal problem. So it's going to be 62.5 plus 450x equals, distribute 50 plus 5x. Do a little math, right? Subtract 50, subtract 50, subtract 4.5x, subtract 4.5x, and you get 12.5 equals 0.5x. Now here's an easy way to do this without a calculator. 0.5x is sitting as 1/2 x. And this is, well, we'll deal with that in a second. Right, and then from here we can just go, okay, multiply this by 2. Right, multiply with reciprocal. And x equals 25. So I need 25 pounds of mixed nuts to make my trail mix that costs $5. There you go. Let's do one last one. Kendo and Candy wax cars. I don't want to get into it. Candy can wax a particular car in 60 minutes. That takes a long time. Sorry, Kendo can wax a car in 60 minutes, and Candy can wax it in 80 minutes. Candy needs help. They plan on waxing the same car together, and they want to know how long it would take. Well, so again, and all this stuff, blah, 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 right? Candy to do it in 80 minutes. I can't get over their names. Kendall could do it in 60 minutes. How long would it take them to do together? You just go 1/80 plus 1/60 equals 1/x. Right, so now we know the rate that Kendall and Candy could wax cars in quotes. So, how do we solve this? How long would it take them to do together? Well, let's find the LCD, right? That's how we just solve this. LCD, try to figure out what 80 and 60 both go into. I am not sure. It looks like, I'm just trying to, what did 8 and 6 both go into? 24. So 2400. Sorry, 240. It's not the same thing as 2400. That's my LCD, right? And you have two choices, right? You could get all of them have the same LCD, or just multiply everything by the LCD. Any way you want to do it. I'm gonna do a way that, in general, most people would tend to like, is just try to get them all to have the same LCD. So I get that, and you're like, okay, what did I gotta multiply 80 by to get that? And that'd be 3x. And you go, okay, what did I multiply 60 by to get that? And that'd be 4x. And what's multiply x by to get that? And that'd be 240. So, once you get that, right, you just add the numerators, and you get 3x plus 4x equals 240. So 7x equals 240, divided by 7, and x equals 240 over 7, which I have no idea, but I have a calculator. Turn it on. 240 divided by 7. So together it's going to take about 34 minutes, so half an hour. It's about 34 minutes. So again, together it will take them about 34 minutes to wax a car. Still seems like a long time. But there you go. And that's the lesson. So you see right there, there's more to the notes about solving inequalities. You would do that next year in math analysis, non-math analysis, because it does get a lot more involved. But for now, that's it.